As far as the CDC guidelines.
Okay.
So can we ask for the homework first?
What?
Can we ask from questions from the homework?
Of course, you can always do that. Want to know this? I'm not changing.
Yes, ma'am. Okay, I have a problem with 9 and 10 on 3.4.
Okay. Any other questions from the homework? Please, if you don't want to put them on chat. The 9 and 10, you said, Roxanne? Yes. All right. Please, other questions? You're going to be tested on it.
Number 2 on 4.1.
Number 2 on 4.1. Okay.
I know what number 2 is.
All right. So we're going to start in order. Yeah, I saw that. So we're going to start with an order, problem number 9 and 10, and then we proceed to the other one. Okay, number 9. Here's the problem.
Wait, this is number 9 or from which section? I'm sorry.
This is 3.4, right?
Okay.
Yeah. So let me take a pencil because I can erase. So number 9 on section 3.4.
And then number 7 for 3.4 as well.
All right. So I'm going to start 9 because I started. Let us say you invest $1,000 in an account where the interest is compounded annually, and after 10 years you have 14,024.29 in the account. What was the interest rate? So let us read the problem. So initially you invest $1,000. That's how much you invest. The rate is
It'll be annually, right?
yes, it's compounded annually. Okay, compounded annually. Compounded annually. Very good. Now, so that's initially, that's compounded. After 10 years, you have earned, of course, interest, and after 10 years, you have 1424.29 cents in your account. So initially 1,000, after 10 years, 1,424.29. And the bank is give you an interest compounded annually. So the question is, find the rate. Means how much rate? What's the rate that the bank is giving you? So you start with 1,000, 10 years, you have 1,424. So of course you earn a fair amount of interest in 10 years. But the question is, what was the rate? So how can I find the rate? I know the initial. I know that I want the rate. Ideas?
It's an equation.
It's absolutely an equation. Let's see what's the equation. So we're going to call f of t. What we're going to call f of t? The amount in the bank, that's my function. So let the f of t be the function. So every time t in years, assigns the amount of money in the bank. In the bank after t years. Okay, what do we know in this problem? I know that initially I had 1,000, right? I know after 10 years I have that much, and I know the formula that governs this problem. What is the formula that governs it? If I call R the rate, what's the formula? Initial,
that
go ahead.
it's 1,000 times 1 plus 0.01 r to the
Okay.
10th power.
Let's not write 0.01 r, write r. It doesn't really
okay.
matter. And then we write it into decimal to the power t. Is this the formula for annually compounded? Initial,
Can you
1
tell me?
plus r to the power t. Do you agree with me on this?
Yeah,
What do we want?
you want R,
R. What's given to us?
everything else.
Almost everything else. So after 10 years, I have that much. I'm going to use this information and plug it here. It means after 10 years, so f of 10 is 1,424.29. What does this mean? If I plug in 10 here, it means 1,000, 1 plus r to the power 10 is 1,424.29. And now I need to find r. I stop for a second. And I want most of you guys tell me we follow what you're doing.
You said you want our thoughts?
No, yeah, do you understand what I'm doing?
Yeah.
Yes.
What do we do first? Do we divide by 1,000?
First, did you understand the setup?
You
Yeah, I
divide by
understand.
1,000?
Yeah, now, first we have to isolate this term. No way out. We have to isolate it. So as you said, rightfully so, we're going to divide by 1,000 both terms. So divide by 1,000. This is going to give me 1 plus r to the power 10 is 1,424.29 divided by 1,000. Okay?
Which is 424.29.
Yeah, so it's going to give me
So that's my
1.4249. Okay, just use your calculator in case you have any problem with that. Now, I want to solve. I have to the power 10. How can I basically, and I want this now. What do you want me to do? How can I get rid of the 10?
Wait, are you gonna like take the 1.24 to the 10th power so you can get
Not to
rid
the
of the 10?
10th power, not to the 10th power.
You're going to use the root?
I have to use the root, absolutely. Because if I take this, the idea is I have to get rid of the 10 here. So it means I'm going to take basically the 10th root of that equal to the 10th root of this.
Okay.
Right? What's the benefit? What's the 10th root of 1 plus r to the 10? That's the 1 plus r. And what's the root of that? All right. Only the calculator can figure this out for me. So how do you find something to the 10th root? It means you take it to the power 1 over 10, or you use something that your calculator have. So this is going to give me 1.42429 to the power parenthesis 1 over 10. So I am getting, I don't know if you guys get the same thing. I'm getting
1.03600. Yeah, I got the same thing.
So we can stop there because there are 2 zeros. We're getting that much. So what is the R? So that's basically giving me the growth factor. So my R is, I take away 1.036. It means the interest rate is now in percent, 3.6%. All right, so the problem really boils down to solve an equation. 1 plus r to the 10. The only way I can solve it is first I need to isolate this. So I divide it by 1,000. Now I want to get rid of the 10. So I take the 10th root. That's how I can get rid of the 10. I take the 10th root from both sides, giving me with r. Question before I go on.
No, I got it.
Okay, all right, so let's look at number 7. All right, so what does number 7 tell you? What's the effective interest rate earned by investing 3,000 in an account earning 4% compounded continuously? So account earn 4% compounded continuously. And the idea is that with the continuously, it means basically we're always getting interest on our money. So we're getting a lot of interest on the money. What's the effective rate? And I gave you basically the formula for the effective rate. So the effective rate is e to the r minus 1. That's really what my effective rate is. And the reason, first we computed and then I explained a little bit the reason one more time. So the effective rate is e to the 0.04 minus 1. So the effective rate is, e to the 0.04 minus 1. So it's 0.0408, and there is a 1 here. So it means 4.08%. Means you can think of this account as if you're putting your money and at the end of the year, you're getting 4.08%. But that's really what the effective rate means. Effectively, you're getting that much interest per year. The advantage is in this that you can pick up your money almost any time you want. Let me a little bit see if I can convince you where this formula coming from. So that's how we do it. Where is it coming from is the following. If the rate is compounded continuously and my initial amount is 3,000, it means the formula is e to the RT or 0.040. That's the formula. Okay. Now, that's where the difficulties is. I rewrite that in the following format. E to the 0.04, the whole thing to the power t. Now, why will this give me the effective rate? That's t in years. Because if we go back, if I give you an exponential function and I tell you the formula is 3,000, 1.02, let us say, to the power t, the simple formula. I tell you what is the growth.
You're getting really quiet.
What? Okay.
I can barely hear you. I don't know about anyone else.
Are you guys having trouble hearing me?
No.
No.
No, because I mean, in my house it's very quiet. Let me tell you that. Nobody is allowed in the room.
I got 1.04 for.
Yeah. Give me 1 second. 1 second.
Oh.
1 second. Let me tell you one question. Suppose, forget about this problem for a split of a second. I give you a problem like that. I tell you what is, and t is in years. I ask, what's the growth factor? You tell me 1.02. And what's the growth rate? 2%. So if my formula is written like a, b to the t, is a t in here, you can figure out your growth factor and growth rate. So the idea now, if my formula is a little bit messed up and I don't have something to the power t, I rewrote it so it will be a, b to the t. When I write it this way, this is my b, which is 1.0481. That's my growth factor. So my effect, my rate is gonna be 0.048, which is what I got over there. So that's really what the formula is coming from. I take 4 to the power t, I rewrite it as a to the bt. The only way I can rewrite it is to do that. And this will give me, after a year, by how much money how much money is growing by. So we get the 1.048 from this idea. So that's really what the math behind it. And the formula is very easy. Okay, any other question you guys have?
Number 10, because it doesn't have the answer. I just want to make sure I got it right.
Dijon, can you hear me? Or you still having a hard time?
I can hear you. It's really quiet all of a sudden.
Okay, so I look at number 10 and then we go to the next section because I want to spend time on it. Number 10. So initially we invest 1,800 initially. Oh, sorry, that's the initial. And the interest is compounded monthly. So monthly. After 6 years, we're gonna have 2,328.74. And the question is, find the rate. Not effective rate or anything, find the rate. I'm gonna treat it exactly the same way I treated the previous problem. Okay, so f of t is the function that for every t, give me the amount money after t years. Okay, now f of t follow a specific rule. We know what f of t is. It's the initial times. Because it's monthly, it's 1 plus the rate that I don't know what it is, over. So monthly, it means over 12 to the power 12t. That's the formula. But I know that after 6 years, I have that much. So it means if I plug in 6 for t, I should have 2,322. So now I'm gonna make use of that. So 2,328.74 is the 1,800 times 1 plus r over 12 to the power what? To which power?
What?
What's t? What's t in here?
6.
72. Oh.
Right, to the power 12 times 6. All right, so I'm trying to be slow. So now I have an equation, basically, where my unknown is r, and I have to find it. So before I do that, I want to multiply 12 by 6 to make it really easy, and then proceed. So I'm going to write this term here. It's going to give me 18,000. 1 plus r over 12 to the power. Now 6 times 12, it gives me, it's 2, and it's a 72, equal 2,328.74. And now,
1,800.
what?
Wouldn't it be 1,800 instead of 18,000?
Oh, I'm sorry.
Yeah, it's 18.
Oh yeah, thank you very much. Otherwise, the bank is taking, I don't know what the bank is doing. Okay. All right, now, as before, I need to isolate this term. So I need to divide both by 1,800. It's 2,328.74 over 1,800. Okay, now to do the math a little bit simple for us, we're going to divide and then we see what we get. So I'm going to take 2,328, no, I meant 3,200, sorry, 2,328.74. I'm going to divide this by 1,800 and I'm getting 1.2937. And now, what am I supposed to do? I have to the power 72.
Square root it.
Root it, 72nd root.
Right, we have to take the 72nd root. We don't really have any way out. So 72 equal the same. Over 12. And now I need a new piece of paper and finalize this. Okay. So let me finalize it. And I'm gonna get the following. Okay. This will 1 plus r over 12 equal. Now I'm gonna take my calculator. I still have the answer here. And I'm gonna take it to the power 1 over 72. And I'm getting, I hope you're getting something similar. I'm getting 1.0035. Of course, I'm not gonna stop after the 20. It's not gonna make sense. I have to move a little bit. Now, it's a simple equation. I wanna solve for r. So I'm gonna subtract 12 from, subtract 1 from both sides. Gonna give me r over 12. I still take away 1 from here, 0.0035. And then I'm gonna multiply by 12. So I can multiply by 12 here, by 12 here. And this leaves me with 0.035 times 12. And finally, I'm gonna get 0.0035 times 12, leaving me with 0.042. So the rate was compounded monthly 4.2%. Okay.
But if you didn't round, it's 4.3.
I got rid of my
Round.
calculator, so I don't know what the numbers were.
It was 0.0430000308. That was like, I didn't round any of it at all.
Okay, yeah. Then if you don't round any of it, you get a better estimate than I did. Yes. All right. Any other questions from this section? So now let's move to logarithm, which is we have to get it. So logarithm, the question was number 2, section 4.1. So number 2, section 4.1. Number 2. All of it, Josh? Right. So number 2. Before I even look at number 2, I have to ask you the question. What does, when I say log n, natural log of n, what I'll be looking for? What's the natural log of n?
The value.
The power
The value of what?
E, of
It's
E.
the power of E. So looking for Ln, it means I'm looking for this power that give me n back. That's the picture. So the value of the Ln of n is the power of E that gives me n. If we keep this picture in mind, the problem becomes actually simple. So let us do some of those problems. What is the Ln of E squared? It means what play the role of n now? E squared is playing the role of n. So again, it means what should I put here so that E to that give me E squared?
2.
2. That's it. Okay, now we keep along the same line. What is Ln of E? Again, we keep the picture. E equal E. That's 1. But that's the power. That's really the power. Now, we keep at it. I may skip some because we have a lot to work on today. ln of 1. Okay, it's this.
0.
Right. I'm looking for that which give me 1. E to the 0 give me 1. Keep at it. So now ln of 1 over e squared.
Oh, I know.
I was confused on this one.
Yes, again. All right, I know you're confused on this one. It means the question is the same. E to
Negative
which power is 1 over e squared?
It'll be
No, it's
negative.
not what?
It'll be
Negative.
negative 5.
No. No. Let us remember crucial. We have to remember that. At the beginning of the semester.
Is it -2?
Right.
Yeah.
It's -2. -2. What's a to the minus n? What does it mean to raise something to a negative power? It's 1 over a. We don't change n, we just change the sign. It becomes n. And that's crucial. Okay? So 1 over e squared is e to the -2. So now the power here is -2. So ln of 1 over e squared is basically ln of e to the -2. It means it's -2. Josh, is it making sense? Josh, can you hear me?
Yes.
Okay, is it making any sense?
Yeah.
All right, so let us do another one. Probably I will not do all of them. E is exactly the same. F is easy, I think. Let me look at the G. What is the ln of the square root of E? So again, the square root of E, E to which power? Give me the square root of E. Josh, can you answer this question?
Oh, I can answer it.
1/2.
I can't hear you.
1/2.
1/2, exactly, because what's the square root of, what's the fractional exponent? So this is a good place to remember the rational exponent. A to the 1 over n, that's the nth root of a. So this is e to the half, that's a half. Okay, so those, keep them in mind. Those, you're gonna need that a lot. So now let me finalize with, I'll pick one more. And let me see which one. ln of the cubic root of e squared. Okay, so basically, e to which power give me the cubic root of e squared. So what really boils down to is asking ourselves, how can I write this term as e to a power?
2/3.
2/3, exactly. Because remember, if you guys, I mean, you have to remember because I'm going to be testing you on those. A to the n over m, as I said before, this is the root, and this is an. Or, because we can multiply power, this is the nth root of a, the whole thing to the power n. That's what we talked about at the beginning of the semester. So this is e to the power 2/3. So this is ln of e to the 2/3, which is gonna give me 2/3. All right? Any more questions before I start today's lecture, which is crucial?
No.
Okay, very good. So now let's go back. So the whole time we're gonna spend logarithm, and this section is really building up why we need the logarithm for. So I start, of course, with reminding you what's the log of n, what's this new notation called log mean. That's the exponent of 10 that gives n. So log n is y, mean y is the power of 10 that gives me n. So I'm asking you here a very simple question. So this, the lecture note have problems in them. Once we finish, I will rescan the whole thing with the solution. But now I don't want to give you answers. That's why I'm not putting answers. I'll ask question. 10 to the log 6 is equal to what?
No idea.
Wait,
I know. I know, no idea. That's why I'm gonna
Six.
keep bringing it back to the picture. What is the definition of log of 6? What is log of 6?
so it'll be 10 of what power?
It will be, yeah. So what is the definition of log of 6? It
What
means
does it
when you are computing log 6, what are you computing?
The power of 10 that gives you
The
6.
power 10 that gives you 6.
It'll be
So
6.
if I take 10 to the log of 6, what are we actually gonna get? What's the definition of it? That's the power of 10 that gives you 6. So 10 of that is exactly 6. Why? Because that's the definition. Because when you take your calculator, when you take this calculator and I compute 10 to the power log of 6, I'm gonna get my 6 back. Because what's the definition of the log of 6? Connect the dot here. What is the log of 6? It's this power. It's the number that I have to put here to get 6. It means this number here is what the log of 6 is about.
That still kind of doesn't make sense though.
That's the definition, Loxan. That's the definition. So when I'm computing log 6, what am I computing?
I don't know.
Okay, let me take easier numbers.
But I'm looking at it like 0.778, right? Is that what that says?
Yes, but 0.778 is what? Is the power of 10 that gives you 6. That's the property of 0.718.
So then if it's, I don't get it.
I know it's hard, but it have to sink in. If I tell you what is, sorry, what's 10 to the power log of 10?
10,
What's the log of 10?
1,
Why?
because 10 times 1 equals 10.
Because 10 to the power 1 is 10. Because
Right.
log 10 is the power of 10 that gives you 10, give you 1. So log 10 is what should I put here to get 10? So log of log 10 is going to give me my 10 back. Because log 10 is 1 itself. Because that's the power here that gives me 1. So the definition of the log, what's the log 6? Is 0.778. Where is the 0.778 coming from? It's what I should put here to get my 6 back. Okay, what's the log of 10 to the 6? That's easy. That's easy. That's 6. Yeah, and that's easy. There is nothing really hard because what's the log of something? You're looking for the power of 10 that gives you 10 to the 6, and this power have to be 6. Okay, so that's easy to understand. This is, you have to think about it because that's what the log of 6 is. It's what I should put here to get 6 back. So the property of the log, and everything I'm going to talk about for the log will carry for the natural log. But now I focus on one of them, the other one will be the same. So the first step, log 1 is 0. True or false?
True.
True.
True. Log 10 is 1. True or false?
True.
Crucial. 10 to the log of anything will give me the anything back. So
True.
10 to the log n will always give me n. Log of 10 to the n will give me n. Then log n is defined only when the number is positive. I cannot have a log of a negative number because if I take 10 to any power, I'm going to get the positive number. So these are the properties that we've talked about And I want you to keep thinking about that. Now, the logarithm has another set of properties. And those are going to be the hard one also, that are extremely useful. So what are the other set of properties that are very useful? I mean, that's what's going to really help us to take off. Suppose A, B, two numbers. And I take the two numbers and I multiply them and creating another number. And one of the property of the log tells me that the log of this new number, which is the product, is the log of the first plus the log of the second. Okay?
Plus.
Plus, crucial. Those has to be drilled. It's a plus, you don't multiply them. So the product is turned into a sum. The product turned into the sum. The other property of the log is, again, very important. Log of A to a power. So if you take a number A, you raise it to a power, you have a new number. You take the log of it. The second property tells me that you can take this power down and it gives me n times log to the A. Okay, so for example, let's just use this, use the calculator to at least to convince you using the calculator, nothing more than that. So let me take a piece of paper and let us play a game for 2. So what 2 is telling me that, suppose I take A to be 2 and N to be 3. 2 is telling me that if I take the log of 2, which is A, to the power 3, it's the same as 3, the power, times the log of 2.
Can you scoot it up? I can't see.
Can you see now?
Yes.
That's what it's telling me. Now, I mean, of course, there is a mathematical reason for it, but first let us understand what it's really telling me. So it means that if I compute the log of 2 to the power 3, and I compute 3 times the log of 2, I get the exact same answer. That's what?
Is that log to 2 to the third power?
Yes.
Okay.
2 to the power 3 equals 3 log 2. I will write in a darker color so you can see. So that's what this property tells me, the second one. So let me try another number. Suppose I take A to be, I don't know, 4, N to be 16. What the second property tells me, if I take log of 4 to the power 16, it's the same thing as 16 times the log of 4. That's what it tells me. Let us again check this out on our calculator. So if I take log of 4 to the power 16, sorry, log 4 to the power 16, and I take 16 times the log of 4, I get exactly the same answers. That's what property B tells me. Now, property A tells me the following. So I'm going to play the same game with A. A tells me that if you have two numbers and you multiply them and you take their log, you get the same answer as the log of the first plus the log of the second. So for example, suppose I take A to be 2 and B to be 3. And I compute the log of A times B. And then I compute the log of A plus the log of B. What this telling me is that you're going to get the same answer. So let us check it out. A times B is 6. All right, what's the log of 6? So I'm going to compute the log of 6. Log of 6 is 0.7781. And the second one tells me it's the same thing as taking the log of 2 and adding to it the log of 3. You get the exact same answer. Let us check this out. Log of 2 plus the log of 3. Exact same answer. So that part, those two properties is really, really telling us. The last one tells me that if you take A over B, so if you have the quotient, so you have a new number, then the log is minus. So this will be turned into a minus. We're going to refer to those property over and over and over and over, basically till the end of the semester.
Is that minus?
Yes, minus.
Okay.
You have the notes in front of you, right? Because this is on your notes. Yeah,
No,
this
I'm
is
writing
minus.
it.
Yeah, this is minus. Okay, so product turned into a plus, A over B turned into a minus. What's not true, so these are the properties that you can use and I will use. What's absolutely not true is that if you have the sum of two numbers, you cannot do anything about it. It means you cannot break the sum. And you have log of A over B. It's not the log of A over the log of B. You cannot break it, is the difference. So those are the properties that I will be referring to over and over and over today and next time and the time after. So before we start using those, let us play a little bit of a game. So I'm giving you the log of 2. I'm telling you that's the log of 2. And I'm giving you the log of 3. And my question is, evaluate the following without using the log button on the calculator. So I want you to compute those, but I don't want you to hit the log of it. I just want you to compute them using the properties of the log. All right, so let us start with the first one. How can I use this piece of information to find the log of 6, which is I did a minute ago?
A would be 2.
Add.
What?
Would A be 2?
Yeah, A will be 2. So I rewrite this as 2 multiplied by 3, which is I'm not changing. That's what 6 is. So as you said, I will take this to be A and this to be B. And this is going to become log of 2 plus the log of 3. So now I can compute that without actually having to hit the log button. And the only reason I'm doing this so we can practice the properties, not because you're going to do that. So this is going to give me that. And of course, I have some rounding. And this is going to give me the answer. Now, I will not get exactly the log of 6. I will get it rounded a little bit, but that's okay. You have to practice those properties before. So 477. And I'm getting 0.778 based on that. Okay, what's the log of 8? Use those to give me the log of 8. What do you think I am after? Unfortunately, I did it a minute ago. 8. I'm going to write it 2 to the power 3. A is 2. And so here I'm using the second property. So that the property tells me you can bring your power down, you multiply it by the log of 2. So what's A in my scenario? A is 2 and it's 3. That's how I am using it. And now I just plug in what I have. 3 times 0.301, which is going to give me 3 times 3 is 309, 0.903. Okay. Now, log of 3/2. I'm going to use property 3. This is A and this is B. And this is going to tell me log of 3 minus the log of 2. So according to my numbers, it's 0.477 minus 0.301. So according to me, I'm going to get a 6 and a 7 and a 1.
What is that, 3/2?
3/2, yes, 3 over 2. Okay, So let me check. What is the log? According to my calculator, what's the log of 3/2? It's 0.176. Even my calculator is giving me very much the same. All right, log 12. I want you guys to give me the log of 12. I give you a minute to figure it out. Use this, and you use the properties and figure out the log of 12. So these are the properties. And I want you to figure out log of 12. You know log 2, you know log 3. Figure out log 12 using those properties.
Well, using log 2 and log 3? That's what you
Only, yes.
2 squared and 3?
Only 2 and 3, but then you can do whatever you want. You have a lot of properties to play with.
It'd be a times log of a plus the log of b, right?
It will be what? Repeat.
A, or in this case, the number representing a,
Which is
times
what?
the log of a times the log of b, or plus the log of b.
What is A?
A is the number that
Squared.
at the bottom. I don't know what it was.
There is
Can't use
nothing
A.
at the bottom. There is no, it's just log of 12.
You
That's
gotta
what
use
I want.
numbers. Can we do 2 squared times 3?
It was the log of 2. 2 was our a number, right?
Log 2.
Yeah.
Okay, I got it. I got it now.
Roxanne, you are on the right track. That's what
It's-
I have.
2 log 2 plus
Uh-huh.
log 3.
Very good. So I'm going to repeat what Roxanne said, but a little bit slower. 12. I'm going to write it as 4 times 3.
Where'd you get the 4 from?
What's 4 times 3?
12.
12, yeah, but like I thought we were
Factors
using
of 12.
3 still.
Yeah. But 4 is 2 square times 3.
Oh, okay.
All right, I'm trying to connect that. Now, this is my A and this is my B. So now this is going to become plus the log of 3. My only goal in those problems is to help. Now, this is the power. I can bring this all the way down. So that's become 2 times the log of 2 plus the log of 3. And I'm done because log of 2, I gave it to you, which is 0.301. 0.301. Log of 3, I gave it to you, 0.477. And now I just add and multiply. I have 0.602 plus 0.477. And then that's going to give me a 9, a 7, and I'm going to get 1.079. And I'm going to check how well we're doing. Log of 12, 1.079. We are doing very well.
You show me the equation for this one, like the A. Oh, not that, like the A and B one.
Yeah, go up. Where you have the 3. Yeah, those.
Those are the properties.
Okay, there's
Okay.
A to B, A to the
But you're combining number 1 and number 2 for this one.
Yes, I'm combining a lot. I'm combining a lot. All right. We're going to do another problem along those lines till it becomes a little bit, till you become more familiar with. So another problem is the following. This time, I'm not going to give you numbers. This is practice 2. I tell you, log A is a number P. I didn't give it its value, but don't worry about it. And the log of B is some Q. My question is, express the following in terms of P and Q. Are you with me on the question? Express the following. So again, the properties are there. These are the properties I'm gonna play with, and I'm gonna do the problems. So my first problem is the log of A times B.
I know.
All right. Which property I'm gonna use?
Number
1, 2,
one.
3. Number 1. So that's the easy one to get us started, to basically help me figure out what I'm trying to do. The answer is P plus Q. Okay, so just practice properties. Now the second one. Log of A to the power 3 times B. I give you a minute to do that.
Wait,
And
I have a
then-
question.
Yes.
So I put log P plus log Q. That's not right?
That's absolutely not right. Absolutely not right. Because P represents the log.
Oh, it's the answer. Okay.
It's the answer, it's the output. So you can think of A as the input of the log, P is the output of it. So instead of giving Q log 2 equal a number, log 3 equal a number, I said, all right, let me give them symbols. Okay, the second one. You have a minute to figure it out.
I can't see it.
I'll write it big right there. Now you can see it, I'm sure. It's the log of A to the power 3 times B. And I want it in terms of the P and the Q. And you have to be very precise which property you're using and how you're using each property. And that's absolutely crucial.
I think I have it, but I'm not sure.
Okay. It was ready. I don't want this time Roxanne, I want somebody else.
3
But I
log
don't
A,
like your, what?
3 log A plus log B. I don't
3
know
log,
the P and Q though.
3 log A plus log B.
Yeah.
This your answer? Sorry.
Well, that's not my finished one with the P
I
and
know, but let's get here. Wait, what's the first line? How did you do it?
Q. I used the I don't know that.
The second property.
Yeah, that one.
No, not yet. You cannot use the second property. You have to use the first property.
I don't know. I just did it all in one.
I know,
swoop.
I'm aware of that, but I want to do it slowly. First property, a product, we turned it into a sum. That's the first property. Then we use the second property. That's a power. We can bring the power down 3 log A. Finally, okay, there is nothing left. I tell you, okay, well, I'm gonna call this P. I'm gonna call this Q. That will be your answer. Okay. All right, we can proceed along the same line. I want the log of A over B squared. A over B squared. Again, there are the properties in front of you. No, they're in front of me, not you.
Wait, what are we doing right now?
A over B squared. A over B squared. Again, you have to use the given property.
A,
Which one you start with? You do it slowly, slowly.
number 1.
Number 1, I don't know.
No, it'd be number 3.
It has to be number 3
Oh, my
because you
bad.
have A over something. So it's gonna be log of the numerator minus the log of the denominator. It's the log of the numerator minus the log of the denominator, which is gonna give me the log of the numerator minus. Now I'm gonna use property 2, and this will have to come down here. 2 times the log of b. And it's gonna give me p minus 2q. Okay?
Now, it makes more sense now how you're doing it than it did the other way with the numbers.
Wait, I have a question.
Yes.
Is that 2 times log B or 2 times log A?
The first is log a
Mhm.
minus 2 times the log of b.
Yeah, your paper
Now-
isn't as clear as usual. Like it's a little bit blurry.
Oh, really?
Not,
It's a
yeah, it's
little
not
blurry.
focused all the way.
I will use the focus. In a minute, I'll put focus, but I lost the paper I'm working with. What is the other, sorry, right here. Now log of b times the square root of a, and then I will put it here. Now this is the question. Log of b times the square root of a. And I'm gonna try to focus it, see if it helps any. Doesn't seem to like it. Okay, I will get rid of the light also.
What if you zoom out a little bit so it could focus?
I tried to zoom out, it doesn't really work, honestly. I mean, that's what I tried. You can't read at all? Okay. All right. Who finished this?
Me?
Anybody else?
It's probably wrong.
I don't know
No,
if it's
I wouldn't say that.
It seems right. I don't
it's
know.
number 1, right?
Yeah, log of b times square root of a.
So wouldn't it would be log, I don't know. I kind of got log of square root of A plus log B. That's where I'm at.
Okay, so it's the log of b square root of a.
I have one question.
I'm listening.
Can we flip A and B? Can we put square root A times B?
Yes, because
Okay.
you know those are numbers. 2 times 3 is the same thing as 3 times 2, correct?
Right.
That's the same thing. All right, who's ready?
Sure.
I put 1/2 log A plus log B.
You're
Not
correct.
finished.
That's correct. So first, it's a product. So I use the product go to the sum. So far, so good.
Exactly where I'm at.
What?
That's where he's at.
So that's the log of b, which is, I know what it is, but I don't know the log of the square root of a. I know the log of a. So now we're gonna use what we know, that this is a to the power 1/2. Now that I have my exponent, I can take it and bring it down. And this is gonna give me 1/2 times the log of a. Now the log of b, I called it q. The log of a, I called it p. That's the end of the problem.
But if you put 1/2 P plus Q is still right, right?
You tell me, you answer this question. Is 3 plus
Yeah.
5 the same thing as 5 plus 3?
Yeah.
That's exactly the same. It's just numbers, okay? Now the last one I gave was, usually I'm more organized, I'm losing the paper. Okay, I'm trying to see what I gave you the last one. 100. So the last one now is log of 100 A3 B5.
Oh, Jesus Christ.
Properties have to be used, and you have to go take your quiz.
Would this be log of A to the third power plus B to the fifth power plus 100?
Tell me what to write, so I make sure. I'm looking at this as the product of three
Right.
terms.
So it would be
Yes.
100 plus log of A to the third power
Yes.
plus B to the fifth power, or log of B to the fifth
Log. Plus
100.
log.
Oh, plus log. Oh, so
Log.
what we do? Oh, log of 100. I'm sorry.
Oh, dirty.
Log.
Okay.
Log of 100. Now, the rest is simple. 3 log of A plus 5 log of B plus, what's the log of 100?
2.
Quickly.
2.
2.
Good
Because
job.
10 to which power is 100? 10 to the power 2. And now it's just 3p plus 5q plus 2. Okay, so the goal of those problems is basically to learn how to use those properties to finally be able to solve our original problem. Is if I have 3 to the power t equal to 2, how to find the t, which is my original problem, is how to solve equation where the power is the unknown. That's really my original problem, how to solve equations where the power is the unknown. Okay.
So, and then an important rule, right, is you had to distribute the log to every term in the parentheses.
What are you talking about?
Because I didn't know that the log was going to go on 100. I thought 100 was times A for some reason.
No, log of 100 is 2, because what's the power of 10, which give me 100? 2 plus 2. Yes, you're allowed to put 2, if this is your question.
Okay.
Okay. Now, I have definitely to let you go, and I will extend the time on the quiz for a little bit because it's already there. Now, ln, even though I didn't really mention ln, the natural log has the exact same property that the log does. So everything I said about the log carry over to the ln. And in the notes I gave you, I actually wrote all the properties again. So for next time, what I'm going to ask you to do on the top of the homework I gave you, I want you to finish basically page 4, 3, and 4 of my lecture. You guys finish them, I go over them, and then we finish. I'll do something. Okay? All right. Now I want you guys to go to your quiz. Since I took up 5 extra minutes, I will definitely give you extra 5 minutes. You can get started, and please try to download it. Please try to download it. Okay, any question before I let you go?
What, you download it and print it?
No, you don't have to download it. Sorry. Please upload it into Blackboard.
Upload it.
Upload it. All right, I'm staying with you as usual, so if you have any questions, so I'll get started.
Oh, you don't want us to leave the classroom?
It's up to you. If you stay here, I can answer your questions. If you leave, I cannot answer your questions.
Oh, okay, gotcha. All right.
That's about it. It's really up to you. It doesn't matter to me.
Professor, I have one question.
On the chat.
Oh, only on chat?
Yes.
Okay. I put it in chat.
Yes, yes, yes.